Okay, we've finally come to the last problem in the problem set, problem number 14. And here we're given a graph of a derivative, and we're asked to answer a few questions and then construct a graph of the original function based on the graph of the derivative. So we have here this function on a closed interval from -3 to +3. And we want to find out for what values of x does f have a relative minimum and a relative maximum. Justify your answer. For the first, we know that we'll have a relative maximum whenever the first derivative changes from positive to negative. And from the graph, this only occurs at x equals -2. At x equals 0, it goes from negative to positive, and at x equals 2, it goes from positive and bounces off of 2 and stays positive again. So the only relative maximum is at x equals -2. Now for relative minimum, in the same way, the relative minimum will occur when f prime of x changes from negative to positive, and looking at the graph, that occurs only at x equals 0. Next, we want to find out where the graph is concave up. And the function will be concave up when the second derivative is greater than 0, and that means when the first derivative is increasing. From the graph, we can see that the first derivative increases from -1 to +1, and then from 2 to 3. And that gives the two intervals on which the function is increasing. Alright, that's basically it. And from there, we're going to construct a graph, a possible graph. We can't be exact here because we're only working with the first derivative. And what we do know, though, is that the function is concave up, or rather concave down from x equals -3 to x equals -1, because the first derivative is decreasing there. It's going to be concave up from x equals -1 to +1 because the first derivative is increasing there. It will be concave down again from x equals 1 to x equals 2 because the first derivative is decreasing there again. And finally, it will be concave up from x equals 2 to x equals 3. At those places where the graph changes concavity, there will be a point of inflection. So this graph then has 3 points of inflection, one maximum and one minimum. And it will be concave down from x equals -3 to x equals -1 with a relative maximum occurring in that interval. It will then be concave up from -1 to +1 and will have a relative minimum at x equals 0 in that interval. It will then be concave down again from x equals 2 to x equals 3 and concave up from with a point of inflection at x equals 2, concave up from 2 to 3. So we're going to draw the graph at this point. Okay, as we've stated, we have concave down from -3 to -1 with a relative maximum at -2. Is then concave up from -1 to +1 with a relative minimum at 0. It is then concave down from x equals 2 to x equals from x equals 1 to x equals 2, and concave up from x equals 2 to x equals 3. Now there is one piece of information that we're missing here. We're also told that at x equals -3, the value of the function is 0. So it's easy for me to do. I'm just going to shift that whole graph downward so that we meet that criteria and add that point onto the graph. So this is a graph again that is concave down from -3 to -1 with a maximum at x equals -2. It's concave up from -1 to +1 with a minimum at x equals 0. It's concave down from 1 to 2 and concave up again from 2 to 3. And we have met all of the criteria, and we're done with all 14 problems.